So these properties are, for example, you have been given a determinant of a matrix, any matrix, okay, and if you want to multiply with any number, so what you need to do, for example, if you wanted to multiply with 2, so 1 over 2 should be outside, and 2 will be multiplied to and rest of the entries will remain the same. 3 1, 3 2, 3 3. Okay, so the point is that when you are multiplying with any number in matrix, a number is multiplied to all the entries, but in determinant it will multiply to a row or column only. Okay, that is the important thing. For example, if you have a matrix A and it is written as 2 4 6 8 in determinant form, okay, and if you would like to take 2 outside, 2 common, so it could be taken out from any row or any column, not from all the entries. Okay, so for example, if you decided to take a common from first row, so then it will be 2 outside and 1 and 2 will remain here, 6 and 8. So you could see here that in matrix all the elements affected, but in determinant only any row or any column is affected. Okay, because we have just taken common from the first row. We have taken, if you multiply 2 inside again, so you will get 2 and 4 again. You recover back by multiplying again. Okay, so similarly, for example, if you wanted to get 2 from the second row, so 2 multiplied by 2, 1 2 3 4. Okay, so it means that for each row you can get common, or for each column you can get common outside. Okay, so you could not get from all the entries. For example, in matrix is without straight lines, so 2 4 6 8. So in case of matrix, if you want to get 2 out, then 1 2 3 4, all the 4 full matrix, whatever the full matrix, it will be affected when you are dealing with matrix. Okay, so this is the idea of the matrix. But in determinant this situation won't happen. Okay, only a row or column could be affected. Okay, whatever your objective is, according to that. For example, I have a matrix in determinant form, like for example 6 8 1 3. I have this matrix, suppose in determinant. So I wanted to take common from the first column. What could be common? The multiple of, what could be multiple of 6 and 8 simultaneously? 2. So 2 could be taken out. So 3 4, and 1 3 will remain the same, the main point. Okay, the second column will remain the same, and we are considering a common from the first column only. So in determinant, column and rows are affected, column or row could be affected, but in matrix all the entries will be affected. Okay, that is the key point. Now we are moving to the question from the exercise. So these are important type of questions. So if you could consider these question as an examination question as well. Okay. So you have been given ABC, determinant ABC, D, E, F, G, H, I is equal to -6, and you have to evaluate minus A, minus B, minus C to D. So first of all, we will write the matrix that we wanted to evaluate. Three G, 3H, 3I. Okay. So that is the determinant. So so from this matrix, what could be taken out from the first row? -1. Very good. And what could be taken out from the second row? And what could be taken out from the third row? 3. So by taking out all, we will have A, B, C, D, E, F, G, H, I. That is what is remaining. Okay, because we have taken out minus from here, 2 from here, and 3 from here, and what is remaining? A, B, C, D, E, F, G, H, I, and which is equivalent to -6. Okay, this is equal to -6. It is given. Okay, it is given -6. So simply you will have -1, 2, 3 into 6. What is your answer? Minus 36. Okay. Yeah.
Why times 6?
2 multiplied by 3 is 6. 6 multiplied by 6 is 36.
No. Why did we? I know how did you get -1 and 2 and 3?
So this is -6. Sorry. Okay.
Plus 36.
Plus 36. That is the answer. Now we are moving to the second question. Here is the second question, 4. That is similar to what we have done just right now. We have to compute P1, B1, A1, C1, B2, A2, C2, B1, 3, B3, A1, 3, A3, C1 minus 3, C3. We have to evaluate this one. Recording again. So what is the most feasible thing? Of course it is also depending upon you what type of operation you apply. So in my opinion, if you subtract column 1 with column 3, so you will try to achieve, you could achieve your objective. Column column 1 minus column 3. So why I am writing in this format? Because whatever I am writing this side, it won't change. Right side won't change, but the column 3 will be affected. Okay, so it means that B1, A1 and C1 will remain the same. B2, A2, so A2 and C2 will remain the same. And now the changing column is column 3. So how the column 3 is changing? By minus column A and added with column 3. So minus B1 and plus B1 cancel. What is remaining? Minus 3B3. Okay. Now minus A1 and plus A1 cancel, and minus 3A3. Minus C1 and plus C1 cancel, 3C3. That is what have achieved after applying this operation, subtraction of the columns. Okay. Now we could take minus 3 out from column 3. As I told you that in determinant we could take a number common from any row or any column. So in this column 3 minus 3 minus 3 minus 3 existed, so it could be taken out. So we could take out minus 3 and remaining with B1, A1, C1, B2, A2, C2, B3, A3, C3. Okay, clear? And then there is a property of the determinant which says that if you could change, transpose, you could take the transpose of your matrix and it won't affect the determinant. It means that you could change your column to the rows or column to the rows to the column or column to the rows. It won't affect your determinant. So what we are going to do here, we simply writing rows to the column. So B1, B2, B3. So this first row is written in the form of column. The second row A1, A2, A3, now it is also written in the form of column. The third row C1, C2, C3, now it is also written in the form of column. Okay, and here you could see that B1, B2, B3, column 1 and column 2. So if we switch column 1 with column 2, switching column 1 with column 2, switching. So whenever you perform the switching, I told you in the previous class, so in the last class we have decided one of the operation which says that if you switch any row or any column, so minus sign can be taken out. Okay, if you are switching rows or column. So since we have switched column 2 with 1, so we have to put minus sign outside. Okay, So now what is remaining? The same whatever we have. So minus 3 minus 1 multiplied by 7, answer is 21. It's okay. This is the given matrix here. Determinant is 7. So we just replacing the value with 7 to get the final answer. Okay. I'm starting the recording again and will give you what we have done. So at this point, first of all, we have taken 2 outside from the row 1 and A2, A1, A2, A3, A2, A1 is remaining, and then we will add row 1 with row 2. So when we are adding, so A3 plus A3 minus A3 will cancel and B3 will remain, and similarly B2, B1. And at that point, we again multiply by 3. So we could write here operation multiplying row 2 by 3. So in order to do this, we have to divide here with 3 as well. Okay. So we did that, and then we subtract row 3 with row 2 to get this all row formulation, and then finally we interchange column 1 with column 3 to get this shape which is given, and the determinant is given by minus 4. So we place the value here, and then finally this is the answer. Okay.